Okay, this is a video that records to troubleshoot through a test number 1 for electronics technician. And this looks at their ability to read a schematic diagram. So this is a schematic diagram for a audio system, car audio, and what we get them to do is to work out how the battery feed gets from battery, which is 0.4 right there, to battery in blue, to VDD up there, which is for video, voltage drop. Gets to there. Okay, so the solution isn't that simple. It's not directly to the point, but it comes up out of here and goes to there, which has got a little joiner, which that little dot goes up there, up there, up there, up there, and through to this. This one goes there, there, down there, across here, way up the top there, across there, and then joins to the VDD, and that's the solution to the problem. The reason that is that this component here is a regulator. If you have a very good look, you'll see that there's 1, 2, and 3 legs, which is 12.5 volts in and 4.8 volts out, which is leg 3. Okay, so that's number 1. Number 2 is looking at this little bad boy, which is from a car, not a car audio. This is from a telephone system, a cordless telephone system. And what we ask them to do is that to identify the components on this board, printed circuit board, that has the red marking on there. So that's a transformer. This is a telephone jack or RJ45. This is a capacitor, but don't just accept capacitor. Ask them what kind of capacitor it is. If you zoom in there, this is what we call an electrolytic capacitor. These 4 little fellas here with the bands on the end of them are called diodes. That's called a polyester capacitor in red there. This is a reed switch, this blue thing, which is RH. The IC2 is a optocoupler. So what an optocoupler is that it isolates the voice from the rest of the electronics. It translates voice into optical sensors, and that isolates the circuit so you don't get electrocuted when the line gets hit by lightning. D8 is a diode, but it's a particular type of diode. That's called a Zener diode. Okay, and then that's a resistor. If they know the resistor colour code, you're a winner. What else is on there? More electrolytic capacitors. That's an IC. These bad boys over here are RF tuning slugs. That is a potentiometer, this one here, this bit here. More electrolytic capacitors, and it's called a variable resistor, a trim pot. You put a screwdriver in the middle there and you can adjust the resistance on it. That's a ceramic capacitor, that green one. Okay, so there's 4 types of capacitors, and these are on the interview questions if you have a look under electronics tests, and you'll see. Now what's wrong with this particular bad boy is that I put the wrong power supply in it about 30 years ago and burnt the crap out of it. This particular, it was a protection device, and it did its job, but unfortunately burned the crap out of the rest of it. And that's the, so you're looking for people that know the various components and the types of electrolytic capacitors. I think I've said electrolytic, polyester, ceramic, which is that one there, and tantalum. Now tantalum you won't find on here because they're normally only found in printed on surface mount. All right, so we move on to test number 3. I'll just zoom this out a bit. Okay, so this is a main board for a heating ventilation unit, predominantly to do with gas heating. And the main thing is this is powered here by 32 volts AC. I think I actually used 28, I measured it before. 28 volts AC. What you get them to do is basically tell us what's wrong with this particular device. Now, there's a range of different things that are wrong with this device. There's a few components that are missing. As you see over here, people have used this to take components off. But if they can sort of give you an indication of where the voltage, what you're looking for is someone who picks up, puts one lead on one and then uses the voltmeter to trace through. Now, if you have a look at that, it's AC volts. Now, once it gets past the rectifier and the diodes, which are here, these are your diodes, it should change to DC. And there's no volts on that. And there's 1.2 volts AC on that. Same as that one, and nothing coming out the other end. Oh, there is on that one. Nothing on that one. On that, that's all right. It's got volts across it. So we then switch over to DC, which is basically push this blue button on this here, and that changes it from DC, from AC to DC. Just like the band, AC/DC. What you're looking for is them using the probe and having a look at various parts and seeing if there's DC. There is DC on that one. This is the main IC. And if you have a look at this IC, you'll see that there's a little dot, an indentation right there. Well, that indentation tells you that that pin will be number 1 down this end. What you're looking for is the ability to diagnose any faults. You expect them to turn it up the other way, like this, and check out what's going on underneath. You can see how someone beforehand has traced the circuit to work out where it's gone. What you're looking for is the ability to just give it a go and have a crack at it. All right. Now, so the third one for this job, or fourth one, is to actually crimp a cable with the cable set. Doesn't matter what they are. I've been using the little bullet point crimps, which are these things. These ones make very good test leads. Okay, and that's pretty much it, with one extra job, and that is to do some soldering on a kit like this. Now, there is a kit in the kit box underneath here, electronics test in there, and you'll find a kit which hasn't been filled in there.